In this video, we are going to look at chemical bonding, part 2, the formation of ions from atoms. By now, we know that an atom is made up of 3 subatomic particles: electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, while neutrons have no charge. And we know that an atom contains an equal number of protons and electrons. So positively charged protons are always equal to the negatively charged electrons. And as such, this atom is electrically neutral because it has no charges and it cannot conduct electricity. So an atom has no charge. So when you look at this image, it can help us analyze this concept better. When you look at this atom here in the nucleus, it has 7 protons. These are positively charged. However, it also has 7 electrons. These are negatively charged. So if you have 7 positive charges and 7 negative charges, the overall charge, if at all these charges cancel out the effect of the opposite charges, we shall have 0. So basically an atom has no charge. We have seen that an atom is a neutral particle. So in the same line, we can say that an ion is a charged particle, one that does not have 0 charge, so a charged particle. So how is it formed? It's basically formed when an atom, which is a neutral particle, loses or gains 1 or more electrons. However, we know that atoms can either be metals or non-metals, and in this case we are going to start with the metallic nature. So a metal loses its outermost electrons to form a positively charged ion, and in this case we can call it a cation. And we shall later realize that the number of positive charges carried in a cation is equal to the number of electrons which will be lost by the metal atom. So how do metals become charged particles? In this case we have sodium. Electronic configuration of sodium is 281, meaning that sodium has 11 electrons. And for this sodium atom to have 11 electrons, it must also be having 11 protons. However, sodium will lose 1 electron under the column of electrons lost. You realize the electron it will lose is this outermost electron, and then it will have 2 energy levels, which is 2, 8. So under our ion side, we shall realize that sodium has 10 electrons because it has lost 1. However, it will still be having 11 protons. So before the sodium atom losing its electron, it has 0 charge because it is still an atom. But on losing this single electron, it now has an overall net of 1 positive charge, because 11 protons with 10 electrons, it means you have a net charge of 1 positive charge. That's why on the sodium ion we write the symbol and then a superscript representing the positive charge. If at all there are 2 positive charges, we write a superscript with a 2 plus, like you can see here on calcium. Feel free and pause and try to do the same workout with calcium and aluminium and see how these corresponding charges come about. So if at all the previous presentation was quite challenging, hopefully with this diagrammatic representation of atoms we shall be able to clear out some of those doubts. So when you look at this sodium atom here, you realize that this sodium atom has 11 protons as shown inside the nucleus. So here we have 11 protons. And then it has 11 electrons. If we are to count these electrons, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Basically, we have 2 in the first energy level. This is our first energy level. Then we have 8 in the second energy level. And then we have 1 electron in the outermost energy level. However, during the formation of the ion, we shall realize that this 1 electron is lost. And when this 1 electron is lost, that means this outermost energy level will have to disappear because we don't have any present electron here. That's why on our right hand side, we shall realize that we actually have 2 energy levels, 1 and then 2. And the new electronic configuration will be 2, 8, because it will have lost this 1 electron. However, the number of protons will remain 11. So we still have our 11 protons, but electrons have reduced to 10. And that means you'll have an extra positive charge of 1. That's why we shall have to represent our sodium ion in this format to show to people that we have an extra positive charge. So we write on the right hand side of the symbol a superscript of a plus sign. Because it's 1, we don't need to write it in this format, because just writing it as sodium Na plus can do the same job. We can't forget talking about a hydrogen atom. A hydrogen atom contains 1 electron and 1 proton in the nucleus. Usually it can lose an electron to form an ion with a positive charge. When this 1 electron is lost, it will only be left with a small positively charged nucleus, and so we can write the symbol of the ion as H plus because it has 1 proton and 0 electrons. Now let's get to the nonmetals. If metals become ions by loss of electrons, nonmetals will readily gain 1 or more electrons to become stable, and in that form they will be forming a negatively charged ion, which we can call anion. And still we shall later discuss and realize that always the number of negative charges on the anion will always be equal to the number of electrons that have been gained by that given nonmetal, as we shall see later on. So how do nonmetals become ions? Let's take an example of chlorine. Electronic configuration of chlorine is 287, meaning that the total number of electrons it has is 17 electrons. And because we are looking at the atom side, that means we should have also 17 protons so that the atom is neutral. However, whenever an ion is being formed, nonmetals will have to gain some electrons, and in this case, to gain a stable electronic structure, it will have to gain 1 electron, and in this case it will form 288, an increase in the number of electrons. That means now this chlorine ion will be having 18 electrons, but the number of protons in the nucleus are still 17, and that means we have more negative charges than positive charges. So the overall charge of this particle will be 1, which is negatively charged. So in this case we shall write the symbol of the atom, and then we shall write a superscript on the right hand side of minus, because it's only 1 charge. However, for some ions like the oxygen or the oxide ion, we shall have a 2 minus to show that we have 2 negative charges, or 2 electrons were gained. So feel free and pause the video and try out the same working for oxygen and nitrogen, and see how we obtain the corresponding symbols for these ions. So using chlorine as our reference non-metallic atom, we shall see that it has 7 electrons in the outermost energy level. However, for it to be stable, it must have a fully filled outermost energy level, and as such it will have to obtain 1 electron so that it gains and obtains a 2-8-8 electronic configuration. In this case, at the start it had 17 electrons with 17 protons in our nucleus, but on gaining that 1 electron, it will now be having 18 electrons. However, in the nucleus it still has 17 protons, and we shall have an overall charge of 1 minus charge. So we shall have 1 but a negatively charged charge. That's why we shall have a chloride minus as the symbol for the chloride ion. So one thing to note is that whenever a nonmetal becomes a charged particle, the name slightly changes. For example, we had a chlorine atom and it changed to a chloride ion. When you have an oxygen atom, it will change to an oxide ion. So we have that slight name ending that changes. However, we also have some common radicals that can exist as negative ions. So we have the nitrate, the carbonate, and the phosphate. For the positive radicals, we have the ammonium radical. So these two sentences, we had them on our previous slides. However, what do they mean? When we say the number of positive charges carried on a cation is equal to the number of electrons lost by the metal, let us assume our cation is this one here, magnesium 2+. This 2 here, the number of the positive charge, is always equal to the number of electrons that have been lost. This is the electronic configuration of a magnesium atom. However, it loses these 2 electrons so that it becomes 2-8. So that's why we say the number of positive charges carried on a cation, in this case it is 2, is equal to the number of electrons lost by the metal, and still in this case there are 2 electrons. The same thing happens for the non-metals. The number of negative charges an anion carries is equal to the number of electrons gained by the non-metal. We had a look at the chloride ion with a minus charge. It had 2, 8, 7. However, it gained 1 extra electron and it obtained a new electronic configuration of 2-8-8. So you realize that here we have the number is 1, although we don't write it. We can't write it like I had shown you initially. You can't write it as 1 minus because it's the same thing. So this is 1, and here we have 1 electron that has been gained. So the number of negative charges is always equal to the number of electrons that have been gained. Thanks for being patient up to this point. We come towards the end of our video and we have our top 2 questions. Question 1. Why do metal ions carry positive charges? Question 2. The number of negative charges an anion carries is equal to the number of electrons gained by the non-metal atom. True or false? Feel free to let me know in the comment section what you think about these 2 questions. Thanks for watching. If you find these videos helpful, don't forget to subscribe and hit that bell notification so that you are always notified whenever I upload new content. Our next video will be about ionic bonding, so let's keep in touch. Be well.